Okay, this one, normal curve review video that we're going to do up here. Remember z-score formula. Zoom that a little bit. Z-score is x minus the mean over the standard deviation. Didn't do that with online students this year, but with my face-to-face class, we drew a picture of a zebra and then a xylophone and a cow going mew over a snake. So if you need help remembering that, you do kind of have to have that, memorized. So if you're, a good artist and you want to do that and impress me, you could try to do I don't know, that's a really long-tailed zebra. But there's my zebra, which is Z equals a xylophone, which is that thing, musical instrument with the little bars on it. Okay, and then sorry, this is going to be very crude, but then I even had it where it had on the top of the xylophone, it had the two little mallets that made an X. So you knew it was X minus. And then I don't know, I couldn't think anything when I was doing this one. So I made it a cow saying mew, okay, over a snake. There's our snake with his forked tongue, but he's shaped like a sigma. So if that helps you remember, it's just a goofy way to remember it, and it's kind of fun. All right, so x minus the mean over the standard deviation. Remember, you always subtract the mean. It tells you how many standard deviations you are away. On the AP exam, it will have the statistic minus the parameter over the standard error, the statistic. So it's not always the same. And what do I mean by that? I'm going to write on here because it's a little bit easier to write. I should have drawn my zebra. I would have done a better job. But for instance, if we go big B minus little b minus big B, if we're doing the slope formula, that the statistic is the slope that came from the sample. That's the little b. It'll be the one in the printout, the A on top and then the B, and you subtract usually 0 for that T statistic if we're comparing this to the chapter. And then over the standard error of the slope, which is also in that same line. Okay, but let's jump in to just some AP stats type questions. This one's a pretty good review question. It says the lengths of individual shellfish in a population of 10,000 shellfish are approximately normally distributed. So as soon as it says normally distributed, then it gives you a mean and a standard deviation. You know that's a z-score. Now that can use a normal CDF. So have your normal CDF on your calculator function ready. Which is the shortest interval that has 4,000 shellfish? Now that's a weird way to say it, but 4,000 out of the 10,000, what we're looking for is we're looking for 40%, because that'd be 40%. Okay, so it's got all these intervals. Now, which one's the shortest? You have to understand that with the mean, the shortest is always going to be the ones that have the mean in the middle and contain because you get the most if you contain the mean and you're equal distance from both sides. You're going to get the highest percent. Okay, so we are going to do this 0 to 9.949. So I'm going to go menu 6.5. I'm going to do a normal CDF. This is a question everybody should be able to get. And this one goes 0 to 9.949. And the standard deviation is 10 with or the mean is 10 with the standard deviation of 0.2. This actually gets us about 40%. Okay, so this could be the answer, but we're looking for the one that's the shortest. And if you're going from 0, since the mean is up here at 10, and we're going 0 to 9.49, you're talking about the curve being like this part of the curve that has 40% from that area on down. So that's not going to be the answer. It does have 40%. If it's the only one that has 40%, then it would be the shortest. Now you can subtract those numbers and we can find that that would be 9.949 wide. 9.949 minus 0. But this one, 9.744 to 10. So I'm just going to go up and I'm going to change my numbers. 9.744 to 10. Well, that gets me 10% in there from 9.744 to 10. So that's not it. 9.744 to 10.256. Oops, what is going on? That shouldn't have done that. Oh, I know what I did. The first one, I messed up on this one. It should have been 9.744 is the lower bound up to 10. Okay, so that one actually was 40%, 9.744 to 10. So I was wrong. This one actually has 40% in it. So this one and this one both contain 40%. Well, B is shorter. It's a shorter span. If you subtract those numbers, it's 0.256 wide. This one, this one's going to be wider. That one's about 80%. That's not going to be the answer. Okay, we're looking for the one that is the least wide. So 9.895 to 10.105. That one's 40%. Now, if you subtract those numbers, 10.105 minus 9.895, the mean is in there. It's 0.21 wide, whereas this one up here, 9.744 to 10, that one's a little wider. So I believe that's going to be our answer, that our answer is D, because it covers the least amount. This one, you can do it. That one is going to not get us the right amount. We'll do it. 9.928. to 10.08. That's a weird range. That's only 30%. So that one didn't work. Was that the end of third period there? I don't know. All right. The distribution of the diameters of a particular variety of oranges is approximately normal with a standard deviation of 0.3. How does the diameter of the orange in the 67th percentile compare? All right, a couple things in here. What's a percentile? Percentile is the area to the left. It tells us it's normal, so we should draw a normal curve, and we should draw a line, and we want 67% over here. Now, since I know if I drew a line at the mean, 50% would be to the left, I knew I had to draw a little bit to the right to get 67% in there. All right, so now this is an inverse norm feature, and but the issue is we don't have all of the information. Okay, so there's a couple ways we can do this. What I'm going to do is I'm going to make my mean be 0 because I want to figure out how much this is. This actually, if I'm smart and I draw the picture, I know I'm not below the mean. I know I'm above the mean. I'm one of these. But now I'm going to do an inverse norm. I'm going to clean up my calculator page here. I'm going to go menu 6, 5. And I'm going to do an inverse norm. And I got 67% of the area to the left. And my mean, I'm going to leave as 0. it says the standard deviation is 0.3. Now, why am I leaving my mean zero? I don't know what my mean is, but if it's zero, it's going to tell me exactly how far above that zero I'd have to be. And it tells me I'd be 0.132 rounded to 2 decimals. So my answer is C. Now, some of these problems, you may struggle on some of these. Remember what I said in one of the earlier videos, and if you didn't watch those earlier videos, remember this now. Do the things you know how to do. If you're struggling on this, just review enough on inverse norms so that you know if you're given a percent, you should use an inverse norm. And then do your best on the test. But the stuff you do know, for instance, cuss and FUDs and the basic stuff that I go through, make sure you know that stuff. Review that stuff over and over so that those you got them down, because that's going to make the difference on your AP test. If you have a problem that you're struggling on and you don't quite understand it, don't spend a lot of time to figure that one out. Just say, all right, that's one that I'm going to struggle on. Learn what you can with some of those. Get better at the stuff you struggle on a little bit, but be really good at the stuff you were good on through the whole year, and you're going to do great. All right, men's shirt sizes. Now, this is an open response question, an old one. Men's shirt sizes are determined by their neck sizes. Suppose they're normally distributed with a mean of 15.7, standard deviation 0.7. Retailer sells men's shirts in sizes small, medium, large, XL. Okay, and they give these sizes. Okay, so it does give us a mean of 15.7, standard deviation of 0.7. You could draw the curve. You could put 15 in here. You could add 0.7, add 0.7. You don't need to draw this whole curve, but subtract 0.7, subtract 0.7. That's old school basic stuff on the curve. Now, this, I don't think I have it on here. Maybe I do. I might be repeating myself later. But from here to here is 68% of the data on a normal curve. Remember your rule. If you go 2 standard deviations is 95. 3 standard deviations is 99.7. Some books call it the empirical rule. We can just call it the 68, 95, 99.7. If you've forgotten that rule, you can come up with it by doing a menu, 6.5, doing your normal CDF. If you're on your other calculator, my apologies. But you can simply go from -1 to 1, leave this 0 and 1, and that'll tell you, hey, that's 68%. You can go from -2 to 2, and you can find that's 95%. And you can go from -3 to 3, and find that's 99.7. Okay, so you should be able to remember those. If it asks you explain using these empirical rule or the 68, 95, 99.7 rule, you need to be able to do that. But A says, because the retailer only stocks in the sizes listed above, what proportion will find that the retailer does not carry any shirts in their size? Okay, so I'm going to do part A. If you were asked this on part A, I had 4 points I always looked for, and there's a reason I have those 4 points. I tell you, you need to draw the curve. So there's some of you who are probably upset with me because you missed the point on drawing the curve. The reason you draw the curve, the reason I have you do these things is so that you get full points on the AP test. So I'm going to do this the minimalist way for the AP test, and then I'll show you, the other parts that you could have. But you should say, all right, the lowest is 14, the highest is 18. So I'm going to put a 14 here. I'm going to put an 18 here. That's the area I'm looking for. Okay? So now I'm going to do this in the calculator with the normal CDF. You can use normal CDF function, but we call that, when grading the AP test, we call it calculator language, calculator speak. We're going from 14 to 18. And our mean was 15 with a standard deviation of 0.7. That's going to find the percent that's in there. Now we're looking for those that won't have a shirt. So we're going to subtract that. All right, so we're going to get 7.6%. So if you use normal CDF as your work, make sure you label that this is the lower bound, this is the upper bound, this is the mean. Put the symbol the mean. All those things show up on your calculator. It's not even stuff you have to memorize. It's all in your calculator: lower bound, upper bound, mean, and standard deviation. So you just can't be too lazy, okay? And I'm not saying that in a mean way. You have it there when you're typing it in. If you got the answer, there's no reason you can't label these. Now that will count as your z-score work. But otherwise, you should do two z-scores where you take 14 minus 17, divide by 0.7, and what are we going to get? We're going to get, brain's not working, -3 divided by 0.7. -4.28 z-score. Then we're going to get 18 minus 15. That can't be right. What did I do wrong? 14. Oh, that's supposed to be 14 minus 15 divided by 0.7. So it's -1 divided by 0.7. So the first z-score would be 1.43 below. And the other z-score, 4.28 above. Now, if you get the z-scores, -1.43 to 4.28, you can use those in here, but then don't replace your mean and standard deviation. Then you leave it 0 and 1, and it should get you the same thing, 92.6. Okay, so this is 92.6%, but it does say what one won't carry their shirt. So you take 1 minus the 926, and you get 7.4% or 7.6% with the other value. When you round stuff, sometimes it falls off, but it's got to be about 7.5% won't have a shirt. Remember, on these, the 4 I looked for was the area shaded, the z-score work, which you'll get normal CDF counted. Otherwise, you do these two z-scores. If you do, you don't have to do both. Then you need an answer, 7.4% or 7.6%, whatever it is, and won't find a shirt, and then you need the context. So next question, I'm doing videos. B. So come on in, but be quiet for a little bit for me. Using a sketch of a normal curve, illustrate the proportion of those whose shirt size is medium and calculate. So our medium goes from 15 to 16. Okay, so I'm going to use the normal CDF. I'll clean up my calculator page again. We're going to go menu 652, 15 to 16. Mean is 15, standard deviation is 2. Now, there is a reason to know these calculator features, because if you're doing multiple choice questions, these save you so much time. The old school way, they would look these things up on z-score tables. I don't even teach the z-score tables anymore. Looking stuff on tables. I had somebody address me one time and say, don't you look up stuff on tables anymore? Looking up stuff on tables is like finding your spot in a theater if you've got seat C17, or finding your seat in an airplane. You should be able to do that. Okay, but the idea is, do you understand what this is giving you? This is 19% of the curve. That's what it found you. This area is 19% of the curve. 19% are medium. Okay, now if this was my test, I'd give you 3 out of 4 points. You have the answer, 19%. You have the context, our medium, and you have the curve. But what you're missing is the z-score work. So you either have to do your normal CDF, or you have to get 2 z-scores. I'm going to do the two z-scores, this one over this one. That's a 0 z-score, and the other z-score is 16 minus 15 over 1 over 0.7.